So what we're going to do today is calculate okay, what we're going to do today is we're going to calculate if I put in this much heat, how much does the temperature change? And what we'll find is that calculating a change in temperature is affected by three things. So when you go to heat something up, three things affect how fast it heats up. The first one's pretty obvious. If you want to heat up a cup of water, you put it in the microwave for a couple of minutes, right? So you put some energy in for a couple of minutes, you get a hot cup of water. What would happen if you wanted to heat up 2 cups of water? What would be different? You need more energy, so you'd have to heat it longer, right? So you had 2 cups of water, 2 minutes in the microwave wouldn't be enough, right? You'd have to put some more time in. So one of the things that affects how much heat is how much you're heating. You throw a drop of water on the stove, it sizzles because it's boiling already. You put a pot of water on the stove, it doesn't sizzle because it's got a lot of mass. It's going to take a long time for it to get up to the point where it can boil. Whereas the drop heats up to boiling right away. Only difference is there's more water in the pan than in the drop. Okay? How much the temperature changes. So if you want a big temperature change, you're going to have to put in more heat. If you want a small temperature change, you're going to have to put in less heat. And the third thing is what material you're heating. Some things heat up faster than others. Okay, so let's look at the material first. Because there are some things that heat up easily and some that take a whole bunch of energy to change their temperature. Try to give you a couple of examples. When you go to boil water, put an empty pan on the stove and turn the stove on. That pan changes temperature very, very quickly. Everybody agree with that? The pan changes temperature quickly when you put an empty pan on the stove. If you put a cup of water in that pan, though, it heats up much, much slower. Right? That's because water is harder to change the temperature of than the iron that the pan is made up of. Or I used to make pizzas, and when you took the pizza out of the oven, we just used a peel and pulled it out, just cooked right on the stone. Okay, and if I grabbed the crust straight out of the oven, I was okay, and I could just grab the pizza and spin it with my hand. But if my finger slipped into the sauce, I burnt my finger. There was a lot more heat energy in the sauce than in the crust. Okay? You may have experienced that the opposite if you've eaten fresh pizza. You can pick it up with your hand, but somehow it burns the roof of your mouth. I used to work in a pizza place, you eat a lot of hot pizza, you lose the top of your mouth pretty often. Okay? Why is it that you can hold it with your hand, but it burns the roof of your mouth? Shouldn't it burn your fingers too? Well, the answer is you're touching the crust with your hands, but the cheese and the sauce are hitting the roof of your mouth, and they have more heat at the same with the same temperature change. Okay, so what we're talking about there is the specific heat capacity. And the specific heat capacity is the amount of heat to change the temperature of 1 gram of a substance by 1 degree Celsius. Now, so the last half of it, heat capacity, how much heat it can hold. The sauce had a bigger heat capacity than the crust. The water had a bigger heat capacity than the pan. Okay. Specific just means that you divide by grams, so it's about the material, not about how much you have. So it takes more energy to change a gram of water by 1 degree Celsius than to change a gram of iron by 1 degree Celsius. And that's why the pan gets hot faster. Okay? So if you wanted to label specific heat, you label SH or for specific heat. And here's the equation. Specific heat equals heat, which is either going to be calories or joules, times divided by mass. Divided by the change in temperature. So it could be joules here. So this sentence right here translates into this equation. Specific heat capacity is the amount of heat, so heat's on the top, of 1 gram, so you divide per gram, and by 1 degree Celsius, so you divide by 1 degree Celsius, divide by degree Celsius. So that sentence translates into that equation. Water has a really high specific heat. Okay, and the number is 1. Why 1? Well, because yesterday, our definition of a calorie was the amount of heat to change 1 gram of water by 1 degree Celsius. So if we compare that to, specific heat capacity, the difference between the definition of calorie and specific heat is if you take out this and write the word calorie, instead of a substance, it's water. That was our definition of a calorie. A calorie is the amount of heat to raise 1 gram by 1 degree Celsius. So if the specific heat is the amount of heat to change the temperature of 1 gram of something by 1 degree Celsius, water is going to have, by definition, a specific heat of 1. Okay, and look at the units. You need all 3 units, because if you look at the math, you had calories on top, grams and degrees Celsius on the bottom. They don't cancel out, so they're all still there. So you're always going to have units like calories per gram degrees Celsius or joules over grams degrees Celsius.